We talk about spring cleaning all the time.
Oh, yes.
It's usually, clearing out the garage, maybe organizing that junk drawer in the kitchen.
Deleting the 1,000 unread emails.
Exactly. But have you ever stopped to think about what it would look like to spring clean the actual architecture of the human mind?
That is a terrifying image. I mean, it's a bit more high stakes than organizing a sock drawer.
Just a little bit. But that is exactly what we are doing today. We are rolling up our sleeves and diving into a massive moment in the history of linguistics.
We are.
We're looking at Noam Chomsky's A Minimalist Program for Linguistic Theory. Specifically, the section with the incredibly catchy title, Beyond the Interface Levels, D-Structure.
It sounds so technical, almost like computer code, but the mission here is actually incredibly human. This text, it represents a huge paradigm shift.
Right.
It's a moment Chomsky looked at the dominant theory of the previous decade, the government and binding framework, and asked a really dangerous question.
Which was what?
Is this complicated because language is complicated? Or is it complicated just because our theory is wrong?
And that's the minimalist in the Minimalist program. The drive to strip everything down to the bare metal. And to do that, we have to identify a villain. In this deep dive, the villain is a specific part of the old grammar machine called D-structure.
Villain is a strong word, but, it fits. D-structure was a load-bearing wall in linguistics for a long, long time.
So tearing it down was a risk.
A huge risk. It meant the collapse of the whole theory was on the table. But Chomsky argues in this text that it's clutter. It has to go.
So our job today is to figure out why. We're going to trace the transition from the old way, where we had these strict, static levels of grammar, to this dynamic, fluid, minimalist approach. We're going to find out why a simple, innocent sentence like John is easy to please completely broke the old rules.
And how fixing that one sentence leads us to a fascinating conclusion about how the human brain processes information, building it step by step, rather than, planning it all out in advance.
Okay, so let's start with the status quo before the renovation, the old way. This was known as the EST or LGB framework, right?
Right. That stands for Lectures on Government and Binding. It was the gold standard for a while.
Okay.
And to understand why we needed to change it, you have to understand how we thought sentences were built back then. Chomsky starts his argument by establishing what he calls virtual conceptual necessities.
Which is a very academic way of saying the absolute non-negotiables.
Exactly.
Yeah.
If you're going to have a language, logic dictates you need two fundamental components. First, you need a supply of parts, a database of words.
That's the lexicon.
That's the lexicon.
Okay, so I have my bucket of Lego bricks. That's my lexicon.
Second, you need a machine to put them together, the computational system. And this machine has a very specific goal. It needs to create a pair of signals, one for your body sound and one for your mind meaning.
In the text, those are PF and LF, right? Phonetic form and logical form.
You got it. Those are the interface levels. They are where the language machine touches the real world. If the machine produces something your mouth can't say or your mind can't interpret the derivation, it just crashes. It's not a sentence. It's just noise.
So far, this all feels very intuitive. I mean, input, processing, output. Where did the old way go wrong?
It went wrong in how it started that process. In the old framework, there was this really rigid operation called satisfy.
Satisfy. Sounds like a candy bar commercial.
It does, but in linguistics, it was a gatekeeper. The idea was before you can start building a sentence, you have to go to the lexicon and select absolutely everything you're going to use for that sentence.
All of it.
All of it. You pull out an array of items and arrange them into a starting lineup.
So if I want to say the cat sat on the mat, I have to grab the cat sat on
everything at once.
E and mat all at the same time before I do anything else.
Precisely. Think of it like mise en place in professional cooking.
Oh, right. Where the chefs have to chop every carrot, measure every spice, and set it all out in little bowls on the counter before they're allowed to turn on the stove.
Exactly that. The operation satisfy was the ultimate mise en place. You select the array. And this arrangement of items sitting there on the counter waiting to be cooked is what we call D-structure.
Deep structure.
Deep structure. It's a distinct level of grammar. It's not the sound yet. It's not the meaning yet. It's just the staging area.
Okay, but I'm a fan of being organized. Mise en place makes for good cooking. Why is having a staging area a bad thing for language?
Because once you create a designated staging area, you have to police it. You have to invent rules for what the staging area is allowed to look like.
Huh?
And in the old theory, we had to invent the projection principle and something called the theta criterion.
The theta criterion. That sounds like a Robert Ludlum novel. What was it actually doing?
It's the rule about roles. Who does what? If you grab the verb hit from the dictionary, hit isn't just a word, right? It comes with requirements. It demands a hitter, an agent, and a hitty, a patient.
Okay.
The theta criterion says. You must assign those roles immediately, right now, at D-structure.
So at the staging area, before I even start cooking, the steak has to already be labeled dinner, and the salt has to be labeled seasoning. Nothing can just be sitting there without a job.
That's a perfect analogy. The old model said, check the rules at D-structure. Then run the computation sound, cook the stew to get to S-structure or surface structure, then serve it up to sound and meaning.
I see the workflow. D-structure leads to S-structure, which splits to sound and meaning. But the text calls this redundant.
Well, think about it from an engineering perspective. We only really care if the sentence makes sense at the end, at the logical form, the LF.
Okay.
If I serve you a stew that tastes like gasoline, it doesn't matter how perfectly I organized the ingredients on the counter 3 hours ago. You're going to spit it out.
So if the meaning level, the LF, is going to check for gibberish anyway, why are we checking for gibberish at the prep station?
That's Chomsky's central argument here. The theta criterion and the projection principle were only necessary because we insisted on having this D-structure level. If we get rid of the level, we can fire the police who guard it. We stop inspecting the carrots twice.
Okay, so theoretically, D-structure is clutter. It's inefficient. But usually in science, you don't throw something out just because it's clunky. You throw it out because it fails. Does Chomsky have a smoking gun?
He does, and it's a sentence that looks incredibly innocent. John is easy to please.
John is easy to please. I feel like I use sentence structures like that all the time. The car is easy to drive. This book is hard to read.
Yeah.
What's the issue?
The issue is where John is sitting relative to what John is doing. Let's break it down. In the sentence structure, John is the subject. He's at the front. John is easy.
Sure. He's the star of the sentence.
But logically, deep down in the meaning of the sentence, is John the one doing the pleasing?
No. If John is easy to please, it means someone else can please John easily. John is the receiver. He's the object.
Correct. So in the underlying logic, John belongs after the verb please. But in the physical sentence, he is sitting before the phrase is easy. And here's the conflict. In the old theory, the subject position for the phrase is easy is considered a non-theta position.
Oh, no, wait.
A non-thematic position.
Okay.
Think of it like a seat on a bus. Some seats are reserved for specific people, the driver, the navigator. Other seats are just empty benches. The phrase is easy describes a situation, not a person. It doesn't assign a role like agent or doer to its subject. It's just an empty slot.
So John is standing in a spot that has no job description.
Exactly. And remember the strict rule of the mise en place, the theta criterion.
Everyone have to have a role.
It says everyone at D-structure must have a role right now. But John is standing in a role-less spot. Therefore, under the old rules, the sentence, John is easy to please, is illegal. It violates the fundamental laws of the theory.
So the all-at-once rule says, John, you don't have a job here yet, so you can't be in the room. But clearly, we can say the sentence.
And that is the paradox. Our theory says the sentence is impossible, but reality says it's fine. The all-at-once rule of D-structure forces us to reject perfectly good sentences because the ingredients aren't in their final meaningful spots at the very beginning.
I assume the defenders of the old theory didn't just give up.
Yeah.
Did they try to patch it somehow?
They did. They tried to work around. They said, okay, what if we don't put John in the array at the start? What if we insert John later, halfway through the cooking process?
That seems reasonable. Just toss the carrot in the pot later. If he's not there at the start, he can't break the starting rules.
It works if the subject is just the word John. But the expert cited in the text, Howard Lasnik, pointed out a fatal flaw in that patch.
Uh-oh.
What if the subject isn't just John? What if it's a complex phrase like, the man who I saw yesterday?
The man who I saw yesterday is easy to please. Yeah, I can say that.
But if you try to insert that whole phrase later, the old mathematical rules of how we build structures just break down. You can't build the internal structure of the man who I saw yesterday, which has its own verbs and subjects. If you're trying to paste it into a sentence that's already half-baked, it creates a derivation paradox.
So the patch fails.
Yeah.
You can't cheat the system.
The system itself is broken. The assumption that we need to lay everything out all at once via destructure is the problem. So, Chomsky says, eliminate it.
So if we aren't doing mise en place, if we aren't gathering all our ingredients at the start, how do we get a sentence?
We improvise. We move to a step-by-step model. The text calls this generalized transformations, or GT.
GT. It sounds like a high-performance car engine.
In a way, it is. It's the engine of the minimalist program. Instead of the satisfy operation where you pick an array, you just have the lexicon in the pantry. And you can go to the pantry whenever you want.
So I grab a word, put it on the table, grab another word, attach it. I build as I go.
Exactly. Computation proceeds in parallel. You don't need a level called destructure because you never have a static moment where everything is waiting. You're constantly building.
This feels much more natural to how we actually speak. But how does the machine, how does it actually connect the pieces?
This is where we get into the mechanics. The operation GT does something very specific. It takes a phrase marker, let's call it piece A, and inserts it into a target piece B.
Okay.
But, and this is the key, it targets an empty position, a null spot.
Wait, if I'm building from scratch, where does the empty spot come from?
The operation creates it. This is a subtle but kind of mind-blowing detail in the text. The empty slot, it's symbolized as, it isn't a word in the dictionary. You can't look up empty slot in the lexicon. The operation GT adds the placeholder and fills it in the same motion.
It's like drilling a hole and putting in a screw simultaneously.
Yes. And the text calls this slot subliminal. It's invisible to the eye scanning the derivation. It's just a mechanic of the machine. Now, here is why this is brilliant. You know the rule, move, like moving a word from the end of the sentence to the front.
Sure, like turning you will eat into will you eat. The will moves to the front.
In the old theory, move was a totally different process than building. But in this new GT model, move is just GT.
How so?
If I grab a word from the pantry and plug it into a slot, we call it insertion.
Right.
If I grab a word from inside the sentence I'm already building and plug it into a slot, we call it move. It's the same mechanical arm doing the same action. The only difference is where it grabbed the material from the box or the board.
Wow, that is elegant. You don't need two separate systems for building and moving. It's just one system, put thing in slot.
Exactly, simplicity. But, and there's always a but, this freedom comes with a danger. If we can just grab things and move them anywhere, won't we make a mess? Won't we build sentences that make no sense?
Right. If I can just grab words whenever, what stops me from saying apple the 8, John?
We need a constraint. But we don't want a rule book of don'ts. We want a law of physics, and this is where the extension condition comes in.
The extension condition. Okay, break that down for us.
It's a restriction on that targeting system, it says. When you use GT to add something, whether you are inserting from the pantry or moving from inside, you must target the edge of the structure. You must extend it.
You have to build outward. You can't reach back inside the machine and tinker with the gears you've already assembled.
Perfect. Think of it like tree rings. You add a new ring on the outside. You can't suddenly decide to add a ring on the inside of the tree. The core structure is sealed.
Okay, always build out. That sounds simple, but does it actually stop bad grammar?
It does, and it does it automatically. By following this simple rule, we accidentally reinvent a very powerful concept called the strict cycle. And the text gives 3 specific examples of bad sentences that the extension condition makes impossible.
Let's look at them. I want to see this law in action. The first one is super raising.
Super raising. It sounds like a superpower, but it's a grammatical error. Imagine the sentence. John seems it is certain to be here.
John seems it is certain to be here. Yeah, that clunks. My brain wants to say, it seems certain that John is here, or John seems to be here. That hybrid sounds wrong.
It's wrong because John is trying to make a massive jump. He's starting at the bottom, near to be here, and he's jumping all the way to the top, past it is certain, to sit next to seems.
Okay, so John is skipping steps.
In the old theory, we had to write a rule, no skipping. But watch what happens with the extension condition. To make that jump, you would have to move John to the subject position of seems, but the phrase, it is certain, is sitting in the middle.
I think I see it. To put John there, I'd have to mess with the middle of the sentence structure.
Right. At the point where you are building seams, the phrase "it is certain" is already built. To insert John where he wants to go, you aren't extending the tree, you're reaching back down into the branches.
And the extension condition forbids it.
The machine effectively jams. It says, I can't place that piece there because I'm not allowed to reach inside. The bad sentence isn't just against the rules, it is geometrically impossible to build.
That's cool. What's the next one? The head movement constraint.
This one is clearer. Take the sentence. Fix John can the car.
Fix John can the car. That sounds like Yoda having a bad day. It should be, John can fix the car, or can John fix the car?
It's trying to move the main verb fix up to the front, hopping over the helper verb can.
Okay.
But again, think about the tree growing. If can is already added to the structure, it's higher up than a fix. To move fix past it, you'd have to perform an operation that doesn't target the very top edge. You'd be weaving things together internally.
The system says no.
No, you can only add to the top.
So fix John can the car never sees the light of day. And the third one.
The Y island constraint. This one is a bit more subtle. How did John wonder what Mary fixed?
How did John wonder what Mary fixed? Wait.
Yeah.
Okay. No, hang on. How refers to the fixing, right? Like, Mary fixed the car with a wrench.
Right. You were asking about the method of fixing, but look at the distance. How has moved all the way out past wonder and past what? It jumped over an island, the phrase what Mary fixed.
I see. If I ask, what did John wonder if Mary fixed? That's also weird.
The issue is crossing that boundary. The extension condition prevents this complex weaving because, again, to extract how from that deep position and place it at the very front, past another question word what, the derivation fails to satisfy the extend-only requirement at that crucial moment.
So instead of a rule book with 100 do not enter signs, no super raising, no head hopping, no island jumping, we just have one physical law. You can only build up.
And that one law naturally stops you from doing all the illegal stuff.
That is the elegance of the minimalist program.
It is. We traded a list of 10 arbitrary rules for one structural necessity.
This brings us back to our spring cleaning. We've adopted this step-by-step building process, GT. We've adopted the extension condition. What does the room look like now? What happened to destructure?
It's gone. It completely vanishes.
It's like that.
We don't need a special level to check who is doing what, the theta rules, because we check them as we pick the words. We don't need the projection principle. And this is the victory lap. Remember, John is easy to please.
The sentence that broke the old model.
Now it's fine.
Walk me through why it's fine now.
Because we don't have a destructure snapshot at the beginning. We don't demand that John has a role before we start cooking. We just start building. We build the phrase to please. We build as easy. Then we grab John. We insert him where he's needed for the structure.
As long as he ends up in a good spot by the time we finish.
As long as the final result works at the interface levels, sound and meaning, the system is happy. We don't care about his status at a level that no longer exists.
We solve the paradox by removing the requirement that created it. That is satisfying.
It is. We are left with a very lean machine. Just the lexicon, the computational moves, and the final output.
There was one little asterisk in the text, though, right? I noticed a note about adjunction.
Ah, yes. The inevitable exception. The text notes that substitution, plugging things into those empty slots we talked about, must strictly extend. That's the core rule. But adjunction is different.
That's when you just tack something on, right? Like adding quickly to run.
Right. Adjunction is like putting a sticker on a suitcase. It doesn't change the internal volume of the suitcase. The text suggests that adjunction might be a bit looser. It might not need to strictly extend the structure in the same way because it's not altering the core geometry.
So if I'm building a brick wall, I have to build straight up. That's substitution. But I can slap a poster on the bottom bricks if I want to. That's adjunction.
That's a good way to visualize it. It's a bit of a rogue element, but for the skeleton of the sentence, the core geometry, the extension condition holds firm.
So let's zoom out. We've gone from a factory floor that requires everything to be laid out perfectly before a single button is pressed to a dynamic, flowing assembly line that builds piece by piece, always moving forward.
And in doing so, we found that the complexity of language might be an illusion. We used to think we needed all these layers of reality, D structure, S structure. Now we see those were just artifacts of a bad theory. The reality is simpler. Take two things, put them together. Take that new thing, put it with another thing.
Which leads to the final provocative thought from the source material, this idea of putting two things together.
Yes, this binary substitution is the core engine. The text suggests that because the operation is always take A and put it into B, all language structure is necessarily binary branching.
Splitting to twos.
Always twos. Never three things at once. Never four. Just 1 + 1.
It's almost digital, zeros and ones.
And it raises a profound question about the human mind. When we look at the infinite complexity of Shakespeare, of legal contracts, of love letters, is all of that complexity just the result of the mind's ability to do the simplest thing possible, merge two objects over and over and over again?
It suggests that at the core of our humanity, there isn't some complex, swirling vortex of magic. There's just a very simple algorithm running on a loop.
And that, to me, is the beauty of the Minimalist program. It tells us that the deepest explanations are often the simplest ones.
A fascinating place to leave it. We've cleaned house, we've thrown out the clutter of D structure, and we found a simple binary beat at the heart of language. Thanks for guiding us through the architecture of the mind.
It was a pleasure.
And to you listening, try not to overthink your sentences today. Just build them one step at a time. We'll see you in the next deep dive.